Hello, geometry, and welcome back to another lesson here in our first unit, Geometry Basics. So if we look at kind of where we have been, we started with talking about what are points, what are lines. Then we also talked about in that lesson line segments and rays. From that, we spent a whole lesson talking about line segments and talking about the length, the distance with segment addition. Then we spent a whole nother lesson talking about rays, how rays create angles, and we looked at how to name angles, how to classify angles, angle addition. Now we're going to look in further into angles and some other relationships and special types of angles. So getting right into it, this first one, what are adjacent angles? Okay, so these are angles that are side by side. Now, when we think about this, angles that are side by side, these are like they are neighbors. Okay, if you think about it, okay, wherever you live, you have a neighbor maybe on your side, or some of you may have a neighbor above or below. Like, I have a neighbor above me, I have a neighbor to the one side of me. Those neighbors would be considered my adjacent, okay? Those are my adjacent angles. Now, something also that adjacent angles have is they share a side, which remember, sides of angles are rays. So they have that shared side, or they have a ray that both of them will have in common. When we're looking at a visual for something like this, for example, there is a picture. A and B are adjacent angles, and what we realize is they share this ray right here in the center. Okay, it's like this ray cut this whole big angle into two parts. Okay, so now let's get in here to the next one. This next one, vertical angles come up quite a bit. These are angles that are opposite or across from each other. Now, this is like if we think about this outside of math even. Okay, if we think about it, if we're back in school and we were sitting, and sometimes your teachers set you in like these pods where you had 4 people at it. Okay, A, B, C, and D. We'll put it that. There is student A, B, C, and D. A and B, you are adjacent. You are side by side. A and D is also adjacent or side by side. They share a side of their desk with B and D. A and C are what we consider vertical. These are diagonal, they are opposite, they are across from one another. The big thing about vertical angles is they're going to share a point, and what we're going to realize is they're going to share the same vertex when it comes to talking about angles. So I'm going to put here, share vertex. The visual that we're looking for when we see vertical angles is you're going to see like an X in the problem. So notice I have these 2 lines, they cross with an X. Right here where they cross, that's going to be the vertex to every one of my angles. If I put this to be A, across or vertical to it would have to be down here at B. Okay, they are diagonal, they're across from one another, and they only share that point in common. Okay, vertical angles always show up when I see an X in the picture. Okay, now going down here to some of our other ones. Okay, we have what are complementary angles. These are angles that add up to make 90 degrees. Okay, these are angles that add up to make 90 degrees. Some ways of remembering this. Some people look and see the C from complementary and they remember C from corner and remember that that makes 90 degrees. Some people also want to look and say they see the C. If they draw a line connecting it, they see the 9 to represent 90 that way. Okay, but complementary are angles that add up to make 90 degrees. Now, these can, I'll say, touch / be adjacent or not. So these can be angles that are touch and adjacent, or they can be separate angles by themselves. So let's look at both versions of this. Okay, let's say they are adjacent and touching. A lot of times what you're going to see is you're going to see a visual like this, where down here at the bottom, remember they have that box? This box, anytime within angles, represents 90 degrees. That's just the abbreviation, remember, for right angles. So if you see that box going over these two angles, that represents those two angles together, give me 90 degrees. So if I mark one of them A, one of them B, A and B would be complementary because they do make that 90-degree angle. Okay, now if we also look at it from the standpoint of them being separate. For them to be separate, and you have to know that they are complementary, you're going to see two angles that are drawn by itself, but you have to see degree markings inside. So notice A I'm told is 50 degrees, B I'm told is 40 degrees. How I know that A and B on the second example are complementary is because when I add the 40 and the 50, I get 90 degrees. So if the angles are not touching, you literally need to add the degrees together to see if it's 90. Okay, if they are touching and adjacent, either looking for the adding to be 90 or look for this box. Okay, and we'll see some other ways here later on when we look at some examples. Okay, the last one on this first page is supplementary angles. These are angles that add up to 180 degrees. Now, really the only difference from this complementary to the supplementary is what they add up to. Complementary angles add up to 90. Supplementary angles, these are touch. These are adjacent. Okay, or they are not, but they add up to 180. Okay, there's a couple things that we see on this. Some people see the S as supplementary and they go right to thinking about last unit we talked about straight angles. Straight angles are ones that are 180 degrees. They see the S, they see the straight. That reminds them of 180. Now, they also, some will look and say, I see the S. If I connect the ends of the S, I see an 8. That is where I get the 180 as well. So notice how on the C for complementary, I connected it. I saw the 9 for 90. If I connect the S, I see the 8 for 180. Okay, now, again, there's two examples we could make for this. One example is that we could have our straight angle, which remember is a line. It almost looks like a straight line, and I could cut it into two parts. A and B would be considered supplementary angles because A and B together make a straight line. And we already know from last unit, straight lines give me angles that are 180 degrees. Now, the other way that you could see this one is I have two angles. And I could look and say I could put the degrees inside the angle. 160 plus 20 gives me 180. So physically, just like we had to do on that second complementary one, I need to add them together, okay, to check to see do they add up to 180 degrees. Okay, now we have one more before we're going to look at examples of these. Okay, the last one, linear pair. Linear pair and vertical angles, when we get into later units, are going to show up as well again. So linear pairs are adjacent angles that are supplementary. Okay, there's only one way linear pairs look. They look like you have this straight line, and it's cut into two angles. We have A and B. That's the only way linear pairs look. Now, you may be asking yourself, well, what about this example that we just did for supplementary? This is still supplementary, but a better way to name it is also a linear pair. Both ways work. These are supplementary, but it also can be named further to be called a linear pair. Okay, linear pair, what I like to stand out is linear, I see line, so they should form a line. Pair meaning that there's going to be two of them. Okay, so now, what we're going to do is looking at those vocabulary that we just went over, we're going to look at these pictures and we're going to talk about what is the relationship between 1 and 2. Notice on every one of our drawings, we drew them as A and B. All that we're going to think about is what if this was 1 and 2 instead of A and B. Okay, so a lot of times when you go through these, you have to ask yourself for the key points on every one of these. So, for adjacent. Okay, remember, adjacent means side by side. So, looking here at A, is 1 and 2 side by side? Do they share something in common? And the answer is no. So, they are not adjacent. Okay, vertical. Are they across from one another? And the answer is yes. 1 and 2 are across from one another. Now, something that we're going to get here to learn, okay, and I can even mention it now, vertical angles are congruent. So, if I know that what one of the angles is, I know what the other angles are. And remember from the last lesson, when we have vertical, or when we have congruent angles, not vertical angles, when we have congruent angles, we show that they are congruent by putting these arcs to showing that they are the same. Okay, complementary. Add to 90. Do I know if these angles add to 90 degrees? No. I don't have angle measures that allow me to confirm that, so these are not complementary. Okay, add to 180 for supplementary. Again, I don't have angle measures to guarantee these add to 180. Okay, and linear pair. Linear pair, before you even say a linear pair, it has to be adjacent and supplementary. So you have to say check marks for adjacent and supplementary, and automatically you can mark this last one. It was not adjacent, it was not supplementary, so it's not a linear pair. This first example is only a picture of a vertical angle. Okay, now we go down here to number B, not number 2, but B here of number 1. There's something that we have to mark before we go any further, and we have to talk about this. This is perpendicular. And remember, perpendicular angles are angles that when they cross, they form 90 degrees. Okay, and really, I have to talk about which lines cross to create the 90 degrees. So this perpendicular or 90 degrees touches this up and down, and also this side to side line. On the other side of that line, and then going down to that bottom one, it also has to be a 90 degrees. And you're going to say, why? And that's because if I know lines are perpendicular, so for example, taking the simplest form of it, if I know that this up and down and side to side line are perpendicular, everywhere that they cross, I can put a box to represent 90 degrees. So 90 degrees in this case can go the whole way around it. Okay, but on every side where they cross, if lines are perpendicular, we can put this box. So since I have this box, this tells me these two sides form my perpendicular. Where they cross here on the other one, I also have to put that perpendicular marking. So now going here through these, side by side. Okay, are angles 1 and 2 side by side? Yes. Now, I'm going to tell you, if they are adjacent, they are never vertical. You cannot have a pair of angles that are both adjacent and vertical, so I can automatically cross vertical out. Okay, complementary. Do they add to 90? And my answer is yes. Notice 1 and 2 create this box. For complementary, either the angles together to create the box of 90, or you're given the physical measurements and you know that they are 90. So these are complementary. If they're complementary, they can never be supplementary, because you can never have angles that add to 90 and also add to 180. And now, linear pair. It was adjacent, but it wasn't supplementary, so it's not a linear pair. For you to choose a linear pair, it has to be adjacent and supplementary. Okay, going down here to the next one. Okay, I look and I say adjacent. Is 1 and 2 side by side? Yes. Now, if they are adjacent, they are not vertical. Okay, complementary. Do these add to 90 degrees? No. I don't see the box, nor do I see the angle measures that allow me to check for it to add to 90 degrees. Okay, are these supplementary? Do these add to 180 degrees? Do they look like a straight line? No. Okay, and then linear pair. It is adjacent, but it wasn't supplementary, so it's not a linear pair. Okay, let's go here to some more. Okay, looking here at D, there's a couple of things that we have to talk about before we can walk through all of these. Okay, and let's start here with this box. Okay, remember previously I talked about, okay, we have to talk about what lines create that box, because that box, remember, represents 90 degrees. Okay, well, if I think about the lines that touch the box, I get this one side to side that I highlighted over pink, and the other line that is touching it is this up and down that I highlighted in blue. Remember, just like we talked about, wherever that pink and blue cross, I need to put boxes all around. So, pink and blue, pink and blue, pink and blue again. So notice in my picture, it ends up that there's boxes all around now. Okay, that's the one thing that I have to talk about. The other thing that I have to talk about is I'm going to redraw so I can see it a little bit clearer. Up there in the top right, there was this diagram. Okay, now we all also do have this. The box is there as well. Okay, first off, this marking means that this angle of 1 and this angle that is not named. Okay, maybe I do this angle A. These angles are congruent. This is the congruent marking. So it is. Now, why they have the tick mark also within the arcs is they wanted you to notice that arc, it looks like in the picture that it's one big arc, but it's two arcs, one in each of those small little portions or small little angles. Those angles are congruent or they are the same thing. We actually have enough information to figure out what the degrees of those angles are. Why I know we have enough is because we know fully angle 1 plus angle A has to be 90 degrees because, let me move this over so you can see that, angle 1 and A together form this box. Now, angle 1 and angle A are the same thing. So really I'm looking for what number when I add it to itself gets me to that 90. Well, simply, if you know that two angles are congruent and they add to 90, I can divide that by 2 and get 45. Each one of those angles have to be 45 because that's the only way that the same numbers will add together to be 90. So now, I'm going to take this back to my original picture. It's going to be of probably some importance to us. So now we can go through this. Angle 1 and 2, are they adjacent? Are they side by side? The answer is no. Angle 1 and 2, are they vertical? Are they across from one another? The answer is yes. They are across from one another. Now we get down to complementary, remember, means 90. Do these angles add together to be 90? Okay, this is what I have to remember. Vertical angles are congruent. They are the same thing. So if I know one of my vertical angles is 45, the other angle down here is going to be 45 as well. So to check complementary, if you know their degrees, 45 plus 45 is 90. These angles are complementary because they do add up to be 45. Are they supplementary? No. If they add up to 90, there's no way they can add up to 180. Are they a linear pair? No. They are not a linear pair because they are not adjacent. They are not supplementary. Okay, let's go down here to E. Okay, I see that box again. I'm going to figure out which lines cross to make the box. And I'm highlighting one of the lines in pink, one of them in blue. Everywhere those blue and pink cross, I'm going to put boxes all around to represent there's 90 degrees. Okay, if you don't want to always see the box, you can simply put 90 degrees instead of the box. They both mean the same thing. So visually, if you don't want to see it, put the number there of 90. So 1 and 2, are they adjacent? No. 1 and 2, are they vertical? Yes, they are across from one another. Are they complementary? So do they add up to 90? Nope. Are they supplementary? Do they add up to 180? Angle 1 is 90 and angle 2 is 90. 90 plus 90 does add up to 180. So these are supplementary. Are they a linear pair? No. To be a linear pair, you have to put a check at adjacent and a check at supplementary. Okay, so there's some examples of just looking at different things. In class, we will look at more of these types. Okay, we will look through the ones where you give like certain reactions, okay, to determine what the angles look like. Now what we're getting into is some algebraic ones. Okay, some where we have to look at the picture and we have to remember some characteristics. So first off, looking here at A, this 112 and the X, what should stand out to me is these are vertical angles. Okay, now what I have to remember is vertical angles are congruent. So what that means, if they are congruent, remember they both get these arcs to show that they are the same. But simply it means, if you know what one of your angles is, I know one of my angles is 112, the other one down here has to be 112 as well. Vertical angles are the same angle measurements. So if you know what one of them is in degrees, the other one is the same thing in degrees. So simply this one had no solving other than to realize that you were given vertical angles in the problem. X has to be 112 in this picture. Okay, now looking here at B. Okay, if I think about what angles I see out of X and 68, I see adjacent angles. First off, adjacent tells us nothing. All it tells me is that they are side by side. Okay, the other thing that I notice on this one is that they are complementary. How I know that they are complementary is the X and the 68, they form this box. This box represents 90 degrees. So complementary angles mean the angles form or they add together to be 90. So if you know you have complementary angles, simply your equation is to add them together and set it equal to 90. Solving for X, I would subtract 68 on both sides. This gives me, if you need to, don't try and do this in your head unless you're comfortable. Okay, use a calculator. I can look and say 90 minus my 68, and I get an answer of 22. So X is going to be 22 degrees. Okay, I have a 68 and a 22 degree angle. Okay, let's look here at some more of these. Okay, looking here at our next one at C. Okay, first off, X and 124. These are adjacent because they are side by side. Okay, another thing is, these form, the bottom of them together form a straight line, so that makes them supplementary. Now, this is where we get that special one. If they are adjacent and supplementary, remember, we can also call them a linear pair. Remember in math, we talk about, okay, mathematicians like to be lazy, so they like to find shortcuts. Just simply writing linear pair is writing adjacent and supplementary together. Okay, so if you don't want to write adjacent and supplementary, every time when you know it's both, simply write linear pair. You're telling me that you know it's both. Okay, if they're supplementary or a linear pair, the special relationship about linear pair and supplementary angles is that these angles add together to be 180 degrees. So simply 124 plus X equals 180. That's how you set up any equation that is supplementary or a linear pair. To solve for X, subtract 124 on both sides. And again, don't rely on your head unless you're comfortable with that. If you're comfortable subtracting all that, that's fine. Okay, you're given a calculator, and I know that it has to be 56. So x in this case is 56. Okay, and specifically if I want to know it's an angle, it's 56 degrees. Now, getting here to D. D is an interesting one because there is a whole mixture. I see linear pairs. I see supplementary. I see vertical angles. Okay, this is one of the problems that it is multiple of these, that what we're going to have to do is go through and solve one at a time. Look for the easiest one first. And I'm going to tell you, vertical angles are the easiest to deal with if you can help it. Okay, and I see that I have vertical angles. Okay, I know this angle is 43 degrees. Vertical and congruent to it is y. Y and 43 are vertical to one another because they are across from one another. So if you know one of your angle measures, remember vertical to it has to be the same as well. So y is going to have to be 43 degrees. Now, after vertical angles, look for angles that create straight lines, or they're supplementary. Because we know angles that form straight lines or supplementary, they add up to be 180 degrees. So right here, I see a straight line, and it's separated into y and x. I already know what y is. It's 43 degrees. If they're a straight line, they add together to be 180 degrees. So 43 plus x equals 180. Subtract 43 on both sides. And again, utilize your calculator if needed. 180 minus 43 is 137. So x has to be 137. So this is 137 degrees. Now, I could solve z for multiple ways. Okay? I'm going to say the easiest is x and z are vertical from one another. So if x is 137, z is also 137. Okay? Anytime you have a picture that is just an x, because we do here in D, if I redraw this picture here in D, it looked something like this. This was where the 43 is. This is where the y is. Those were vertical angles. They are across from each other. When you see a problem that you just have an x in the picture, there's always two sets of vertical angles. So the one was 43 and y. The other one was x and z. Okay, it will always be the case when your problem looks like that. Okay, so now that we've talked about it just numerically, we're getting now into some algebraic. And now on these last few, what we realize is we need to mark the picture. So, looking here at the first one. Okay, I see an information of if PQT is 3x plus 47. So, P to Q to T. Okay, that's up here in this top part. Okay, P to Q to T. Always in between that. They tell me it's 3x plus 47, so I put it in between. Okay, the other thing that I see right here is they tell me SQR. SQR, and in between that, that's where I can put 6x minus 25. Now, I'm going to ignore the rest of the problem. I'm going to tell you, sometimes in geometry, once you have marked some information, stop. Do not read the rest of the problem till you have worked with what you have marked. Okay, if you read the rest of the problem and you're like, oh, they want me to find all of this, you get confused. Do not confuse yourself. After you mark a couple pieces of information in your problem, stop. Ask yourself, can I solve for anything? And my answer is yes, I can. PQT and SQR. These are vertical angles. Remember, on vertical angles, we put these arcs because they are congruent. If pieces of information are congruent, they are equal to one another. And if pieces of information are equal or congruent to one another, when we set up an equation, we set them equal to one another. So 6x minus 25 equals 3x plus 47. To solve for x, subtract 3x. I get 3x minus 25 equals 47. Add then 25 to both sides. I get 3x equals 72. Divide by 3. Again, if you have to use your calculator on some of these, use it. X equals 24. Now, did they want me to solve for x? Now I can read further. No, they want me to actually find the angle measures of these. Start with the ones SQR and PQT, the first two. I can figure out these angle measures just by substituting in. So I can look and say 3 times 24 plus 47. 3 times 24 is 72 plus 47 gives me 119. So PQT is 119 degrees. SQR, that's going to be 6 times 24 minus 25. 6 times 24 is 144. Minus 25 is 119. Ooh, that's a really big O for degrees. So let me just cross that out. 119 degrees. There, that's better. Notice, these better be the same thing. They're vertical. They have to be congruent. So we got 119 for both. Now they ask me about TQR. TQR. Okay, if I have to, cover up. Okay, here's angle TQR and SQR. These angles form a straight line. Angles that form a straight line add up to 180. So 119 plus angle TQR has to equal 180. Subtract 180 minus 119. I get that angle TQR has to equal 61. I can put 61 degrees there. The last angle that they asked me about is PQS. I have another set of vertical angles. TQR and PQS is vertical, so PQS has to be 61 degrees as well. Okay, picking out, I'm going to tell you vertical and linear pairs or angles that form a straight line. Most important things that you're going to see. Okay, let's look here at some more of these. Okay, looking here at this next set of them. If AB is perpendicular to CD. So first off, this AB is if segment AB is perpendicular to CD. Perpendicular. Perpendicular means they form a 90-degree angle. So if AB, I'm going to highlight that in blue, is perpendicular to CD. Okay, everywhere in that blue and the pink, I need to put a 90-degree angle or the box to represent 90 degrees. So now what I need to look for is to mark the rest of the picture. Okay, so looking at this. Okay, the rest of the picture, DCE, from D to C to E, right up here, is 7x plus 2. From E to C to B is x plus 8. Now, I didn't mark anything here else, so I'm going to cover it up. This is what I have marked right now. Okay, looking at your picture, these two angles created this little square. That square represents 90 degrees. If you know angles together form that square to represent 90 degrees, simply an equation to set up is to add them together and say it equals the 90 degrees. So if angles come together to form that, add them together, set it equal to 90. So I get 8x plus 10 equals 90. I get 8x to equal 80. I get x then to equal 10 when I solve. Now, before I go any further, substitute in the 10. X plus 8, that'd be 10 plus 8, so that's 18. This is 7 times 10 plus 2, that's 72. Okay, now, let's find out what it wanted me to find. ACD. ACD. ACD is this angle right here. We already know what that angle is because it has the box. ACD, since it has the box, is a right angle or 90 degrees. DCE. DCE, we already found, we substitute in, that's 72 degrees. ECB, we already substitute in, that's 18 degrees. ACE. ACE. Okay, if I have to cover up, this is the only part that's not in ACE. Okay, for ACE, remember, we did angle addition last time. We know one of the parts is 90, plus the other part is 72. So I'd have 90 plus 72 to give me 162. And then ACB. ACB is a straight line at the bottom. If angles form a straight line, remember those are straight angles, so they're 180 degrees. So a lot of these problems are when you have the algebraic is marking them and like covering up if you have to see certain pieces of information. Okay, let's go down here to another one. Okay, going down here to C. DEG is 5x minus 4. GEF is 7x minus 8. Stop right there. If you have marked a couple pieces of information, okay, I'm going to cover up what I don't have anything else marked. Is there enough for me to do something with on the problem? And the answer is yes. These angles form a straight line. Angles that form a straight line, they are supplementary. They add up to 180 degrees. I can simply look and say 7x minus 8 plus 5x minus 4 has to add up to 180 degrees because they form a straight line. Combining like terms, 7x and 5x is 12x. Negative 8 and negative 4 is a negative 12 equals 180. This would be 12x equals 192 when I add 12 to both sides. 192 divided by 12, I get x to equal 16. Now, before I go any further, let's substitute in. 7 times 16 minus 8. 7 times 16 is 112, minus 8 is 104. If that top angle is 104, I can also put 104 down here at the bottom because those are vertical angles. Vertical angles are congruent or the same. Okay, 5x minus 4. 5 times 16 minus 4. 5 times 16 minus 4 is 76. If the side angle is 76, it's 76 on the other side because they are vertical angles. Vertical angles are congruent. So now, I can look and say, on this problem, okay, what else did they want me to find? I found X. DEG, I found that. GEF, I found that. FEH, I found that. DEH, I found that. DEF, DEF. DEF is this straight line. Straight lines add up to 180. I found that. The only thing I haven't found yet is Y. This Y comes here at this part. DEH is also 9Y plus 5. This fits into some things that we're going to talk about the rest of the year. If you have two pieces of information at one spot, you set those pieces of information equal to one another. At this, I have a 9y plus 5 and a 104. I'm going to set 9y plus 5 equal to 104. If two pieces of the information are at the same spot, we set them equal to one another. Subtract 5. I get 9y to equal 99. Divide by 9. I get y to equal 11. Okay, so we are now done with this lesson. Okay, we've talked about this. We've talked about marking our picture. When we get into class, we're going to practice some more of these. We're also going to look at some problems where maybe you're given it all in a word problem format with no picture. How can you draw that? Okay, but whatever questions you have, ask them now. And I will see you back in class. Have a great day, everyone.